Welcome back. The objective of this video is to help us write mathematical models based on real-world data. And we'll also use our calculator to write different kinds of mathematical models, including linear, quadratic, and other polynomial models. Here in example 1, we're going to plot some data given to us. We're going to draw a line of best fit and come up with an equation for a best fitting line, which is just a mathematical model to fit that data. So let's go ahead and read our data here. We've got an antique dealer who's visited an auction house and recorded an estimated selling price of 6 different antique chests, and then he compared that to his actual data. So we'll make our estimate our x and our actual our y, and then we'll plot everything on the coordinate plane here. So the x coordinates our estimate, the y coordinates our actual, and let's go ahead and plot that data. So the blue dots are our data points and create our scatter plot, and now we will just draw a line that we feel fits the data, and then from that line we'll grab a couple of points and calculate the equation of the line using point-slope form. So the red dashed line is our approximate visualization of our best fitting line. And given that best fitting line, it looks like we have a couple of data points here that we can grab some points on the line. So we'll grab 6, 6, and we'll grab the point 1, 1/2. And from those 2 points that are on our best fitting line, we'll come up with an equation that gives us an estimate of what we can predict for our antique dealer. So based on our 2 points, we'll calculate the slope. So 6 minus 1/2 over 6 minus 1 gives us a slope of 5.5 over 5. So the slope of our line is 1.1. And then we'll put that data into point-slope form and come up with the equation of our line. Now I've correctly put in my point of y minus 6 equals 1.1 times x minus 6. And I distributed my 1.1, and I get the equation of my line is y equals 1.1x minus 0.6. And that is our mathematical model, and you will see this described as y hat equals 1.1x minus 0.6. In sample 2, we're going to use our graphing calculator here to write a linear regression model for the price of oranges in dollars per box. So we've got a data set here, year and price per box. So our year will be our x's and our price per box will be our y's. And in our calculator, we're going to put these into lists. And our x box will be L1 and our y box will be L2. We will start inputting our data beginning with 2006. So our x's will start with 6, 7, 8, 9, and we'll put those in. The other thing you can do is when you're graphing this, keep in mind what your data is here for your x's and y's, because you can use that to set your window on your calculator. So we know that the x's on our calculator, we want to go from like 6 all the way to like 2015. So 6 to 15 will be our x's in our window, and our y's will go from like 8 to maybe $15 or even $20, because we want to extrapolate this out a little further. So some things to keep in mind when graphing your data set and looking at things on your calculator. So the following page in your notes does give you the instructions, but we'll walk through this and I'll show you how to do this on the calculator, but it's also written in your notes here, so you have it as a resource. So I pull out my calculator. I did go into y equals here to see if my plots were on or anything data set in there, and I've got everything all cleared out. So now we're going to go ahead and create our lists. So in order to create our lists, we're going to go under the Stat menu not list, but I go under stat and I'm going to edit, and I'm going to edit L1. Now I don't have any data in L1, but if I did, I could just cursor up to the top of that and press clear and enter, and that would clear everything in that list. But I have no data in there. So now we'll put all my data in L1. So I'm going to put in 6, 7, 8, 9, 10, 11, and 12. So I've put in 6 through 12 in L1. I cursor over to L2, and now I'm going to put my dollar amounts in L2. And I've got my last couple entries, 12.91, enter, and $13.12, and enter. And now I've got all my data entered. I do a quick double check to make sure I did everything correctly. So I see in my notes I was supposed to let 2006 be 1, and I made it 6, so I'm going to have to re-input all my list 1. So I'm going to go to the cursor to the top of list 1. I'm going to press clear, and I'm going to clear list 1, and I'm going to start all over and enter 1 through 7 for those particular values. Beautiful. Now I have those entered correctly, and we'll move on to the next step, find our scatter plot. Above the y equals key, it says stat plot. That's what I want, so it's in blue, so I'll do second stat plot. I want to do plot 1. So I'm going to turn that on. So we'll hit enter. Turn that guy on. It's giving me a scatter plot. It's giving me my list, my marking. It's going to be in blue. The next thing I'm going to do is set my window, and I'm going to use my data set to help me do that. So I'm going to go to window. I've got my x's from -10 to 10. I'm going to start at like -5, and I'm going to go up to 20, and I'll count by 5s. And then our prices went from $8 to $13. So my y's are going to go from, we can go from 5 until 25, and I'll also count by 5s on that. And now I can go ahead and hit graph, and we'll take a look and see what our scatter plot looks like. And there's our data set that we've input. So we can do the trace key, and our trace key will take us along and show us on our scatter plot. But now I want to find the best fitting line. So in order to do that, I'm going to go back to the stat menu, and I'm going to go to calc, and now it gives me different regressions. So we have linear, quadratic, cubic, etc. I'm going to do 4, a linear regression in ax plus b, that's slope-intercept form. So we'll ask for a linear regression. We're going to use list 1 and list 2. So we'll cursor down, and we'll ask it to calculate our best fitting line. So our a value is 0.3571, that'd be our slope, and our y-intercept is 10.388. So now we've calculated the equation of our line. So we'll transfer that data over to our line 5 here. Our y hat, or our best fitting line, is now 0.357x plus 10.389, and we'll put that into our calculator and graph that and see how it looks. So I hit my y equals, and then I'll go ahead and put the equation in, and we'll graph it. And I hit graph, and there is the equation of our best fitting line. Or there's the graph. So the next thing that we'll do, it asks us to find what is the expected price in 2014. Well, 2014 is year 9, so I can go to second calc and value, and I can say x equals 9, and it tells me 13.60 will be my price per box in 2014. So I record the $13.60 for x equals 9. It also asks about 2015. Well, that would be in x equals 10. So I'll go back to my calculator. I'll go to second calc. I want a value when x is 10. And this is why we did a bigger window with larger x's. And $13.96 is our estimate for x equals 10. And then we'll record that on our notes. In example 3, they give us a table of how quickly transmission fluid is drained from a large storage tank. We have a time in seconds and a height in inches, so as time passes there's less and less. So the height goes down, so the height depends on time, so our x and our y, and then so we'll make our time list 1 and we'll make our height list 2. And then we'll put this data into our calculator. We'll get a quadratic function this time, and we'll take a look at that. And then we'll make an estimate, a couple estimates about that tank. So I'm going to enter the data in our two lists. So I'll go to Stat, Edit, cursor over to list 1, and put my x values in 0, 10, 20, 30, 40, 50, 60. Now keep in mind these x values, you'll want to keep those for setting your window on your calculator so you can see those points. I might go up to about 100 for my x's on the window, and also for my y's, the range here is from about 125, and we're going to go to 0 in our window. But let's go ahead and input the data into our lists and proceed from there. So list 1 has our data from 0 to 60. But again, for our window, I'm going to expand on that and make that a little bit bigger when we graph this, and then I'll put my y's in. So in list 2, I have all my y's entered correctly, and we're asked to find the model of the data with a quadratic function. So we'll use our calculator to get a quadratic function. So using my calculator, I go under Stat, so there's my Stat menu, go to Calc, and now we want a quadratic regression, which is 5. We want to use list 1s and 2s, and we'll calculate our quadratic regression. So our quadratic regression, ax squared plus bx plus c is our standard form, our a value, our b value, and our c value, and we'll go ahead and then record those in our notes. So our model, h hat of t, because time is our input or our x value, this should be t squared, and this should be t. 0.00774 t squared minus 2.08214 t plus 123.11905. So there's our function. Use the model to estimate the height of the transmission fluid in the tank at 35 seconds. So I'm going to put 35 in for t and solve. But again, I'm going to let my calculator do some of the work on this. So let's take a look at our calculator. I've input the function into my calculator. I set my window, my x's only go to 60, but I'm going to go up to 100 for my x's, 100 seconds. I'm going to count by tens. And my y's, well, if I drain everything out, it would go to 0, so I'm going to use a y min of -5. That helps me see my x-axis. And a y max of 130, and I'm going to count by 5s. And let's go ahead and graph our function. So you can see our scatter points, and our best fitting line fits the data very, very well. Our next question says use the model to estimate the height of the transmission fluid at 35 seconds. So I can go under my calc menu, and we'll do a value at x equals 35. And it tells us we'll have about 59.7273 inches. Our final question, how long will it take to drain the storage tank? Well, that means we want a height of 0, so we would set our function equal to 0 and solve for t. So how are we going to do that? Well, in order to find that point, what we can do is in our graphing calculator, we can graph the equation y equals 0 simultaneously with our function, which is really just our x-axis. And then we can do an intersection. So under second calc, I want to find the intersection of this function here, our red function, that's our first curve, enter. Our second curve is the equation y equals 0. I hit enter on that. It's asking me to make a guess. I'm not going to. And the intersection is at an x of 87.76. So that tells us it'll take about 87 seconds for our tank to totally drain. So we use the intersection function and set y equal to 0, and we saw that it would take about 87.763 seconds, or about 88 seconds, to drain the tank. So there are some real-life mathematical model problems and learning how to use your calculator, and we'll get some more practice with this when I see you in class.